thanks everyone. I'm just going to do a quick overview of the program, and there's more in-depth information about what we'll be covering specifically and with the itinerary and the syllabus, at least a preliminary idea of what we're covering on the website. So I'm just going to give you sort of the 10,000-foot view of what we're doing from above. This is an aerial view of a Google Earth image of Washington that you're looking at. And this is the Washington Forest Program, Climate Change and Forest Migration. And I am a wildlife biologist, a conservation biologist, a forest ecologist by training. And I've spent a lot of time all over the world doing research and teaching. But I think Washington is one of the coolest places, and I love living here, and I'm excited to take students around Washington. There's some really fantastic sites, and we have a really interesting program. And like Allison was saying, we're going to be mobile. We're going to be moving. We're going to start in Spokane, Washington, but we're going to quickly move out into the forest and go back in time, back about 50 million years, and look at Washington's forest and the climate and how it was different 50 million years ago. We'll actually be going to Washington's only fossil dig site, and we'll be looking for fossilized trees ourselves. And when I first went and did my first fossil dig, I found a ginkgo leaf. And ginkgo used to be much more widespread in Washington state, and now it only exists in tiny parts of Asia naturally. And if you see a ginkgo tree today in the world, it's been planted. So we'll be looking at the past and how climate was different, and then we'll quickly move to the present. And the second week, we'll be doing a lot of ID of trees. We'll be deploying camera traps to try to learn about Washington's forest mammal community. Mammals are harder to study, so we'll be setting up and deploying camera traps and looking at nocturnal movement. Most mammals in Washington are nocturnal. So we'll be setting those up and learning how and why you do cameras, trap studies, and that kind of thing. And then we'll quickly move to the west side of Washington, where you can see on the map, it's dominated by forests, right? And so that green area is all forest cover, and about 60% of Washington is forest. So forests are an important part of Washington's culture, and historically, as well as now economically. And these forests are experiencing rapid change. And as humans are changing our atmosphere and our environment, we're going to be affecting forests, and we already are. So we're going to look at those interactions between climate, the atmosphere, the oceans, and how that interacts with forests. And we'll be going into depth, and you'll get to experience all this firsthand on the course, not just reading it out of the papers, but actually looking and seeing, experiencing, talking to experts, and learning what it means in a globally changing world, what's happening with Washington's forest. So one of the big things that influences Washington forest is disturbance. We'll spend a lot of week 3 at Mount St. Helens Monument, looking at disturbance and succession of forest. And then we'll spend week 4 and a little bit longer backpacking in the Olympic National Park and going up the Hoh River Trail, which is my favorite trail in all of Washington to backpack. We'll be spending time at some of the rivers, the Elwha River in the Olympic forest, and then we'll quickly move then down to Mount Rainier, where we'll finish the class at the high elevation forest. So that just gives you a sense that we will be moving around, we'll be covering a lot of ground, and we'll be looking at a lot of interesting topics on this class. So this just gives you an idea of some of the diversity of landscapes across Washington. And we'll be going to these places, these dry forests, these fossil forests. We'll be going to old growth forests. We'll be going to alpine forests, volcanic landscapes, a lot of different places. So the first place we'll go is these fossil forests, and we'll be looking at these fossils, and we'll be learning how scientists study how past climate affected the forests that were here and why those forests changed over time. And we'll go to Mount St. Helens, like I said, and we'll look at one of the biggest disturbances that has happened in modern US history, and that is the eruption of Mount St. Helens in 1980. So we're 40 years past that eruption. So you can see on the left of your screen, the original view, forests going all the way up to tree line on the volcano, a beautiful lake, very productive forests. They were some of the most productive forests on the planet for logging and for now carbon sequestration. And you can see on the right what happened post-eruption. And so it wasn't a vertical blast on Mount St. Helens, it was a lateral blast, and the pyroclastic blast came out and basically scorched the earth for 7 miles to the north. And so we'll be going to that pumice plain, and it's almost like a moonscape. But over the last 40 years, life has continued to evolve, and succession occurs even in these moonscapes. And so it's really fascinating to see how nature recovers. And 40 years in, there's been a lot of recovery. So we'll be looking at that. And then we'll backpack again, the old growth trail along the Hoh. It's an amazing place to study the aspects of what makes old growth different from younger forests. And these forests are some of the most productive and interesting forests that exist in anywhere in the world. So yes, you can go to exotic places, but Washington has some of the most interesting ecosystems and some of the most important in terms of environmental services. These big trees store a lot of carbon. And so we'll be talking about carbon sequestration and why it's important and how old growth is different in its characteristics than, say, younger forests. And then finally, we'll be learning a lot of dendrology and techniques that scientists use to study forests. And we'll be doing tree ring analysis, and students will learn how to core trees and then process those cores and look at them and read the age of the tree by the core. And so I've shown you a little schematic here that shows the bark and then the year and then how you read back across these growth rings on the tree. And so we'll be doing that kind of work and then using that and applying those skills then to doing small research projects and learning the process of science. Even if you're not a scientist, you'll be learning why science and how science works and how science answers questions about complex problems. And so then we'll be taking these techniques and going to places like Mount Rainier National Park at the most beautiful time of the year when we have an amazing flower blooming in these meadows, and we'll be looking at how forest change and forest movement is affecting these meadows. As climate's changing, the forests are changing. And so those are the kinds of interactions that we'll be looking at, and you all will be out there in the field and learning and experiencing and having fun, and it's just an incredible place to spend 6 weeks to do science and to learn about conservation and wildlife and forests. And again, you'll be doing camera trapping, where we'll look at why you install cameras, how you install cameras, what types of questions you can ask with camera trapping. And we'll learn tree identification, of course. I'm a bird person by training, and so we'll be conducting some bird surveys, and I'll teach you how to do point counts and how scientists look at birds in these forests. And then we'll also, again, be doing ecological studies across these forest ecosystems to learn about Washington's unique and diverse landscapes while backpacking and traveling and learning to cook, and it's going to be a lot of fun. Again, I hope you'll join us on this amazing journey across Washington. And these, again, are just some of the few of the places that we'll be going, but we'll be seeing a lot and experiencing a lot, and it's a really extraordinary place.